Again, thank you everybody for joining this webinar on from carotenoids to fork, the story behind salmon and trout color, benefits, sources, and market trends. In case you have any question, you can use the button on the left on the menu, and we will have like a question and answer session at the end of the webinar. And at the end of the webinar, our team will send links to the PowerPoints and the video recording of the webinar, and also a certificate to all those who participate to the webinar today. We will also have some polls, which we will air later. So I will just introduce myself. I'm Paolo Brai. I'm the founder and director of Friend of the Sea and the World Sustainability Organization, which has developed Friend of the Sea and Friend of the Earth projects, and also the director of international programs of the Dolphin Safe project of the Earth Island Institute. Here with us today are Caroline Candebat of Panaferd marketing and of Panaferd. She's marketing and sales manager EMEA, and also Dominique Corlet of Aquaculture Natural Solutions. I will provide you more information about them. Caroline is PhD in aquaculture and fish nutrition. And as I said, sales and marketing manager EMEA of Panaferd. Dr. Caroline Candebat holds a strong academic and research background in marine biology, aquaculture, and fish nutrition. She completed her Bachelor of Science in Biology and Master in Science in Marine Ecosystem and Fishery Science at the University of Hamburg, including a research period at Macquarie University in Sydney, Australia. So we have also Dominique, with whom I've been in touch for also many years on fish feed certification and related. And he's director of Aquaculture Natural Solutions. Dominique Corlet is involved in the aquaculture industry for more than 30 years, with a diploma of engineer in France and a master's degree in aquaculture USA. Dominique Corlet has been working at various positions as researcher and director of a major fish feed plant. In 2011, he set up the consulting company Aquaculture Natural Solutions based in France, working on various topics and projects, including feed nutrition, new ingredients or additives, processing or quality standards. He was involved in the initial discussion of the first organic EU aquaculture standards. His passion, seafood. So Caroline and Dominique, thank you very much for joining the webinar.
Thank you for having us.
Just a note for the next webinar. It's going to be on the 15th of December at 4 p.m. And it's going to be about the foundation, our foundation, World Sustainability Foundation, coral restoration conservation projects. In particular, there will be more detail about the project in Thailand that we have been supporting in the past few years. So I will just shortly introduce our organization. In particular, I've been involved in the Dolphin Safe project of the Earth Island Institute, which led to a sharp decrease in dolphin mortality in the Eastern Tropical Pacific. And so I realized that certifications could be very important tools to achieve tangible conservation results. And I launched in 2008 through the WSO, the World Sustainability Organization, Friend of the Sea, which initially was focused on certifying products on sustainable fisheries and aquaculture. And 10 years later, we launched Friend of the Earth, which was initially focused on certifying products from sustainable agriculture and farming. In 2022, we opened our foundation, which supports conservation projects in over 40 countries. And in 2023, we opened our first concept store right in the center of Milan, in the highest footfall street in Italy, and it's called Sustainable Friends. There's over 5,000 products from 1,500 companies in over 90 countries around the world, which have obtained the Friend of the Sea or the Friend of the Earth certification. These are the projects of our foundation, supporting projects for conservation of endangered species and habitat in over 40 countries. And so we are the only platform which can, with two consumer-friendly labels, potentially certify the whole range of food products and non-food products and services with the solid 30 years experience and completely independent from the industry that we certify, and also verified by national accreditation bodies. In particular, Friend of the Sea is the only certification which, with the same seal of approval, can potentially certify both origins, fisheries, and aquaculture. And we also have a specific requirement for fish welfare in aquaculture, and very soon also in fisheries. As I mentioned, we are the only third-party certification out there, with the exception of Global Gap for aquaculture, in that we are verified by national accreditation bodies in the US, in Italy, and elsewhere. And we are also recently obtained the IAF multilateral agreement recognition, which is the top recognition which any certification can have. So we are in a short list of 9 certification which obtain this recognition, among them ISO, BRC, IFS, Global GAPS, CEDEX. Over the years, both for Friend of the Sea as for Friend of the Earth, we have extended the scope of the certification to award and motivate other products and producers worldwide to go in the path for sustainability. So we develop standards for nutraceuticals like omega-3, collagen, but also fish feed, restaurants, cosmetics like UV creams, which do not impact the coral reef, tourist destinations, and so on. Similarly, for Friend of the Earth, we develop standards for sustainable textiles and fashion, for sustainable furniture, mining, insect farming, sports, events, and so on. More specifically, I have a couple of slides and considerations about today's subject to provide you also point of view of Friend of the Sea, which is in building, let's say. As far as coloring alternatives for farmed salmon and trout, the subject of today's webinar, the expert speakers will provide you with plenty of information and details. I would like to just focus on for a moment on their environmental impacts. So synthetic carotenoids have a footprint generated by their industrial chemical production, thus energy and resource use. Natural carotenoids from algae and yeast have water and energy footprints from biotech cultivation, at least potentially. Finally, carotenoids from crustacean byproducts, if we do not consider the actual fishing or farming activity and its impact, they would seem to have a lower impact and even potentially be beneficial in an optic of circular economy. So even though the literature of life cycle analysis findings seems to highlight how some impacts of the synthetic ones are higher, while byproducts seem lower and other natural carotenoids moderate, it seems to us that the blanket more sustainable label is not scientifically defensible, at least with the current knowledge about this and the current means of production, without defining the exact parameters and boundaries of the assessment. So for some potential impacts, there is one trend, for others a different one, as you can see somehow from this very summarizing table. Friend of the Sea Technical Committee, however, will consider in the next months for future versions of the aquaculture standard the possibility to include a recommendation to shift to natural carotenoids and maybe a certain percentage of crustacean byproducts. However, it's the technical committee that decides on all these and will vote on the possibility of inclusion of this new requirement, and will, of course, keep you updated. With this, I finish my part of the presentation, and I'm very glad to pass the microphone, let's say, over to Dominique, which I think is the next supposed speaker. Let me get back to our meeting. Here we are, all three of us. I turned off my my presentation. Dominique, I suppose you are the next speaker, right?
Yes, I am, the first one.
Wonderful. And are you able to share your screen? We didn't look into this. Eventually, I will try and see if I know how to do it. Can you? Do you have an option under the screen?
No, it's on your side normally.
Yeah. Okay. I can share your presentation, and you tell me to move on with the slides. Shall we do like this? Otherwise, I would have to find a way to allow you to be one of the trainers. Okay. Maybe I can. I found it. Okay, I transfer the session control to you. Now you should be able to.
Okay. Yeah.
Okay, wonderful. Thanks. Sorry for the delay. Okay.
Can you see my screen now?
Yes, I think also you would like to show the polls now?
No, not yet. In the second half, please.
Okay. Please go ahead.
Okay, thank you, Paolo. Thank you for this webinar. So I'm going to talk about various questions. I hope I can answer all. Some of them are, where does the fish color come from? What are carotenoids? The main benefits? And of course, the different sources in farmed salmonids. When I talk about salmonids, I mean salmon and trout in that case. So what are
we don't see the presentation yet.
No, we don't.
You don't?
I think you asked me if we could see it, but
can you see my screen or not?
No.
No.
Okay.
You have to click on the lower part to share the screen.
Okay.
There's a button on the lower part, on the
Bottom right.
lower side of the. I don't see it anymore, but you should see it now.
Okay. Bottom right. There's nothing left here. Okay.
You're still the co-trainer. So Paolo, you are the trainer, and Dominique, you are the co-trainer. So Paolo, you would need to give Dominique the control.
Yeah, I don't see how I can do that.
Okay, maybe you could start with my presentation I sent. It's gonna be easier if
because I gave you the control, but okay. So
okay, let's
take control. Okay, and I share my screen. I apologize. So let me share your presentation.
Please.
I think it's this one.
Yeah.
Okay. Great. Here you are.
Okay, thank you, Paolo. So go to the next slide, please. So, and then that's the question I was talking about, so we can move on now. And what are carotenoids? That's the first question, and the question I'm going to try to answer. So as I want to start with, color is everywhere in nature, so you can see this wheel of colors showing you the next from the green chlorophyll. So you can see here two very important for plants, as we know, to the yellow form, to the red carotenoids forms, yellow, especially in corns, to the pink ones found in carrots, for example, or orange. So beta carotenes found in carrots gives the name actually to the whole group of pigments. Carotenoids are natural pigments, mostly from yellow to red colors. So it's going to be found in plants, it's going to be found in algae, it's going to be found in insects, but birds as well, flamingo, as we know well. And of course, in fish flesh, especially in salmonids, that's a very symbolic color of salmon and trout. So just for your information, of course, lycopene, very well known, it's found in tomatoes, is part of this famous carotenoid group. So there's more than 800 carotenoids now identified, very important, from algae, red algae, to this flamingo, well-known colors. So two main classes in these groups. On one side, the carotenes, on the other side, what we call the xanthophiles. Carotenes are more basic molecular form with carbon and hydrogen. And on the xanthophile sides, the ones of interest for animals. Most of xanthophils are yellow, actually. But the red ones, such as astaxanthin, we'll talk more about it later, feature a different chemical structure, especially with oxygen bound, which turns them red. But you got even blue ones, what we call the crustaceanine carotenoid found in shrimp or lobsters. It's linked to a protein, so it gives this blue tone, but it will turn red when you expose it to cooking. So we know well when we cook shrimp and lobsters, of course. So what are the carotenoids in salmonids? So as I said, astaxanthin is the main xanthophile found in salmonid. You may find other ones, red pigments one, such as contaxanthin, also well known, adonyxanthin, adonirubin, and so on. All are present in fish in a free chemical form, meaning not esterified. There's no fatty acid branch linked to this molecular and under specific optical isomers. I won't go in detail in terms of chemistry, but I will mention that later on. Salmonids do express color differently. You have differences according to species. We know, for example, rainbow trout is having a much better capacity to store astaxanthin compared to Atlantic salmon. It's the same for some species like coho, the farm salmon coho we got in Chile, for example, having a more deeper color. So it depends on the salmonid species. That's the first difference. The second one is related to wild or farmed. You may have wild salmonids, well known, for example, in the North Europe or Alaska, where they catch wild salmon, having very deep color compared to farm ones. But they could be also very pale at some period of time, and especially to that third point, which is reproduction. Pigments, very important compounds, I will explain why, move to the skin or to the genital organs, while the muscle part will turn pale and even white. It's very impressive. Pigments and color have no impact on taste. Certainly attracting consumers, no doubt, but that's very important to be aware of that. Pigments, many studies have confirmed that point. I'm just adding this table showing you the average astaxanthin concentration according to farm salmon, especially the Atlantic ones. You see 5 to 8 ppm or milligrams per kg. You see the difference with trout, especially with rainbow trout. As I told you, concentration can be much higher. And if you go down, you see especially the microorganisms such as yeast, bacterium, or algae have large concentration. That's really the start of the aquatic chain. If you look at krill, also well known, the astaxanthin concentration is interesting, but not so important at the end. So what are the roles and the properties of carotenoids for salmonids? The first and major ones, key functions, to absorb light, and especially UV, in order to protect the fish shells and all the tissues against all the oxidative damages we got, especially the free radicals. It will include, of course, all the gametes, like the salmon or trout ova, and you got these pictures. This is very nice color. It's not for free. I mean, it's really to protect the eggs, especially in terms of against the oxidation. The color enhancement is also for breeding purposes, especially for males and females. And you got this picture having very bright colors in order to attract both males and females in that case. That's very important the pigments move to the into the skin. It's a well-known precursor of vitamin A, what we call retinol, involved in different functions, but I will mention the visions, I will mention the skin protection, especially the melanin production. That's a very key part of and properties of carotenoids. Very important to remind that the antioxidant properties, astaxanthin, especially all the red forms, are considered to be the most powerful antioxidant, far better than vitamin C and vitamin E. And you can see this graph showing you it's about 6,000 times higher for astaxanthin in terms of antioxidant power or capacity. So that's a very key point, and there is important development now and research, especially for human health, to use this capacity of the antioxidant astaxanthin. The last one, of course, it's health and immunity for fish. It will improve survival during the small transfer, meaning from freshwater to seawater. We need these carotenoids and we need astaxanthin. It's going to be very interesting in terms of protections against some pathogens, especially bacteria, virus, and so on. There's always that question in all stores, I would say, where does the color in farmed trout and salmon come from? For salmon and trout, there's different pigment sources and, of course, some differences. So, as I said, animals, any types of animals cannot synthesize carotenoids and need to find them in their diets. Of course, it's going to be for feeds, include in their compositions in the meal, mixed with the other ingredients, meaning fish meal, soy, fish oil, and so on. If you don't do that, you will get this white flesh color. But of course, we need these carotenoids for the health. As sometimes said, it doesn't come from carrots. I heard that once. It doesn't come from shrimps. Shrimps, the concentration is too low, and the bioavailability is also very low. So it's not so interesting at the end. There's mostly two sources of asta used in the salmon feed. The first one is synthetic astaxanthin, which is the largest one used on the market. And the second ones are natural sources from different microorganisms. And I show you how important or how concentrate they can be in carotenoids. Yes, that's an interesting table showing you the different pigments, the carotenoids used in the feed industry. On the left side, you have the yellow color, beta-carotene, lutein, used, for example, for the egg yolk industry. Very important. On the right side, you have the red forms, such as the astaxanthin, as we talk, which can be either synthetic, artificial, or coming from microorganisms. So let's just have another view of the main differences between synthetic asta and natural carotenoids. Of course, in terms of origin, as we said, on the left side, not found in nature, it's coming from the crude oil origin in that case. On the right side, it's found in nature in three sources: bacteria, algae, or yeast. That's the start of the aquatic and astaxanthin chain. In terms of process, of course, it's going to be complex chemical reaction, what we call the Witting reactions. On the right side, pretty simple process. It could be in an open pond. It could be in tanks for fermentation. In terms of sustainability, you just talk about it, Paolo. Of course, on the left side, we have this decarbonization challenge, the exit of fossil energy. On the right side, we have the needs for carbon footprint reductions when you have this microorganism production. In terms of types of pigments, very important here. Of course, with synthetic asta, you have only synthetic asta in different optical isomeric forms. I will talk about it, and not found in nature for some of them. On the right side, you got wide spectrums of carotenoids You could find astaxanthin, you could find other red ones such as azoxanidine or adenixanthin, with a similar chemical forms found in wild salmon or trout. Here's just a brief slide showing you the three ASTA isomers. At the top, you have the two first ones found in nature and found in the microorganisms I was talking about. If you add the last one, the mesoastaxanthin, that's really a fingerprint showing and proving the presence of artificial ASTA not found in nature. Just some information about inclusion and efficiency. Inclusion in feed, meaning trout feed and salmon feed, is based on the astaxanthin content. It's going to be adjusted by the farmer according to the farm conditions and market, meaning pale fish or very deep red. In Japan, they like very deep red fish. In Europe, it's more or less a bit below. So it's going to be from 25 to 80 ppm or milligrams per kg of feed. Of all, the two forms have pretty much the same efficiency and stability, meaning fresh, frozen, or smoked. As you probably know, color is often measured by the salmon fan scale from 20 to 34. Unfortunately, I should say, there's no visual difference between the two sources. You cannot say which one is synthetic, which one is natural. That's part of the problem. Only clear labeling will inform the consumers. In terms of standards and markets, the synthetic ASTA is only authorized for feed use. It's going to be banned in organic standards, of course, and by some retailers around the world. It's not approved for food use by the novel food regulation in Europe due to the chemical process. For the natural carotenoids, it's a bit different. It's going to be authorized in all markets, including organic, of course. And some products are authorized for food use. I mentioned After produced in Sweden. Very interesting product. You got a slide showing you different products. Trout or salmon. You see trout ova in this can. So used by areas or markets. In that case, synthetic ASTA is really the reference on the market right now. It's found and used worldwide, I would say, more on standard markets. On the other side, natural carotenoids, for your information, it's widely used in Scotland, for example. For the Label Rouge, you see this logo of this great and delicious salmon from Scotland. It's going to come from Iceland or Faroe, using also natural carotenoids. Ireland, the green island, having a lot of organic salmon production. It's going to be the same for premium salmon farms in Norway or in Denmark. Most of the EU trout sector, I was thinking about France, a large producer of trout, is using natural color. And of course, all organic farms. So, briefly, some conclusions and take-home messages. First, red xanthophylls such as astaxanthin are key nutriments. Very important for salmon and trout and involved in many vital functions. Next, pigments are added to this fish diet, to the feed, to ensure the right carotenoid intake for the fish needed first for health and for color. And usually the average concentration is going to be from 25 to 80 ppm. That's the average concentration. There's two main sources of astaxanthin, as I said, either artificial or natural, with overall similar efficiency and, as I said, no visual differences. On the right side, you got salmon. Well, for your information, it's using a natural pigment, but it could be a synthetic form. The synthetic form is still the most widely used on the market, but it's not fully similar to the natural form, as I mentioned and as I told you. So the use of natural carotenoids, as Paolo was mentioning, is really growing in EU, in the North American market as well, especially in the US, or more premium and sustainable markets in terms of image, where natural additives are preferred. Next. Thank you. And then, please, stay healthy, eat trout and salmon. Thank you, Paolo.
Thank you so much. Thank you so much, Dominique. We really learned quite a lot. And I really appreciate also your balanced approach, providing the actual differences and the pros and cons. It is clear that the byproducts from crustaceans origin, from what you explain, from what I understand, is quite a limited one, and it has some limits also in the presence of the carotenoids, right?
Yeah, the concentration is low, so unfortunately, and bioavailability, the ASTA actually molecular is going to be bound with, for example, chitin, and it's going to be tough to use it for fish, especially for salmonids.
Great. So let me pass the microphone to Caroline, and I will share the screen with your presentation. Here you are.
Hopefully you have the newest version of it, but we'll see.
I don't know. This is the one.
That's always the thing.
No, but the one I received from my team maybe an hour before the.
That's all good. That's all good.
Okay, I'm sure.
Let's start. First of all, thank you, Dominique, for introducing astaxanthin and the world of pigments, and thank you, Paolo, for having us here. Hello to everyone. My name is Caroline Candibet, and I'll take you through the second half of this webinar today. So we'll have a look at the story behind salmon and trout color, where pigments come from, and what consumers really think about natural color and synthetic pigmentation in salmon and trout. So let's get us warmed up a little bit with a short poll. I was wanting to run this poll to understand better who's in the room, first of all, and how familiar the European audience is actually with natural pigmentation, or generally with natural pigmentation in salmon and trout. So feel free to answer the poll questions while I'm giving this little presentation. Did you already activate it?
I think, Caroline, you should be able to see them. Can you see them on your screen? Okay, so maybe you can explain them as I show them. I see somebody is already voting.
Some people are already voting. So the first question is, what best describes you? Are you a trout farmer, a chef, a feed manufacturer, or do you just love to eat seafood, or salmon and trout in particular? So in the second question, we then ask, before today, did you know salmon color comes from pigments in feed? I've noticed talking to people that a lot of times people do not actually know that. And some people even assume that fish is dipped into color. So it would be nice to clarify that. The third question is, do you think consumers know salmon color comes from feed? Then fourth question is, if two fillets look identical, but one is naturally pigmented and one synthetic, which one would you actually choose? Then the fifth question is, when you buy salmon or trout or seafood in general, what's the first thing you look at? And then the sixth question, I would like to ask you to look in particular on these salmon colors. Can everybody see the screen?
I will get back to it now.
Thank you. Thank you.
Here you are. So now they can see also the different
okay, great.
colors for the sixth pole, the number 1, 2, 3, 4, 5, 6.
Perfect. So yeah, the first one is pretty light. It's quite an extreme that you hardly find in salmon, at least in store. And the sixth option is quite deep reddish, and it's more of a coho option. But yeah, I will show this image of the salmon fillets at the end of the presentation. And yeah, we'll come back to your results at the end and compare them with our national consumer data that we collected this year. So why are we talking about pigments today? And there are at the moment several strong reasons why pigmentation has become such an active topic across the aquaculture value chain. So from a consumer perspective, color is directly associated with naturalness and trust, and we know acceptance of synthetic pigments has been declining. From a market perspective, the EU salmonid market is quite large, with over 9.4 billion euros, and pigment choices directly influence the product position, especially in the premium and in the organic categories. Also, when we have a look at the innovation sector, we see a shift towards stability of products, traceability, and sustainability. They are really a central focus point now. And yeah, research also focuses a lot on natural alternatives, opposing to non-renewable resources. And of course, the current regulation plays a very important part nowadays as well. In the EU, natural pigments are used in the organic production and only natural pigments. And in the EU, we are also seeing in 2022 that, for example, the synthetic colorant E171 was removed from the list. And in the US, we are seeing a stepwise removal of synthetic pigments across industry. The industry that produces candies, for example, they have been pushed to now use only natural alternatives, natural food dyes, for example, and also ice cream producers. The list goes on and on and on, really, in the US. And altogether, these drivers just make pigmentation a strategic decision and not really a technical footnote anymore. Thank you, Paolo. So in nature, salmon and trout obtain their colors from a variety of carotenoids, as Dominique has mentioned. Not just astaxanthin, but a natural mix of pigments that originate from algae, plankton, and crustaceans. So in aquaculture, carotenoids don't only affect color, they also contribute antioxidants and play a role in supporting the health and the performance of the fish. So when we look at pigment sources for farming, it makes sense to consider solutions that reflect the natural pathway, the natural diversity, really. And here's a little overview of the global pigment options in aquafeed. And this table summarizes the main sources. So we have first the petroleum-based synthetics pigments, which is the most commonly used pigment source in aquaculture. About 80% of the aquafeed share is dominated by petroleum-based synthetic pigments, or astaxanthin in this scenario. Then we have bacterial pigments, such as from Paracoccus carotenefaciens. Then we have microalgae, which is also a natural source for astaxanthin and a whole array of other, and yeast, krill, and shrimp meal. And each source has a different carotenoid profile, stability, regulatory status, and really cost structure. And yeah, the natural sources vary, and some provide mainly astaxanthin, while others, like bacterial fermentation, offer a broader carotenoid mix. For Paracoccus carotenifasciens, it's five main carotenoids. And this diversity, or stability, bioavailability, and potentially even health benefits. So when we talk about natural pigmentation, there isn't just one solution. We're talking about a whole toolbox, depending on species, market, and consumer expectations. And one example of a natural pigmentation option in the aquaculture industry is, of course, Panaferd. Panaferd is produced through fermentation of marine microorganisms called, and I've already mentioned them before, Paracoccus carotenifasciens. It contains a natural spectrum of carotenoids, predominantly astaxanthin, but also adenosine, xanthosantine, and other found pigments that naturally occur in the wild and are being eaten by wild fish and shellfish. It's completely chemical-free, it's GMO-free, and it uses a fermentation process that is stable, consistent, and scalable, which is quite important for the aquaculture industry. This broader carotenoid profile makes it closer to what salmon would just actually eat in the wild. So Panaferd is produced of the marine microorganism, a bacterium, and yes, both the EU and the US are using it extensively. Could you move on, Paolo?
Sorry, Caroline, can you explain when you talk about the origin, is part of it also from the crustacean byproducts?
So the crustaceans eat basically the microorganism Paracoccus carotenifasciens because it lays in the sediment of water bodies. So that's the original. So crustaceans eat the microorganism and therefore develop this coloration. So it's a food chain actually. And in my next slide, you can see that.
Yep.
Can you go another one forward? Thank you. So I've actually written it down here. On the bottom, you see marine microorganisms. And when you move to the right, you can see that zooplankton is feeding on the microorganism. And crustaceans eat the zooplankton that contain the pigments from the marine microorganism. And the wild salmon then eat the crustaceans. So what Panaferd does is, a Japanese researcher actually found this microorganism back in the 90s and has found a way to domesticate the bacterium. So it produces really well astaxanthin and other pigments. And we use a natural fermentation method to break down the cell walls of these bacteria. And within the cell walls, you have these carotenoids, and they are being released into the media, which is then being dried. And at the end, you have a dried pigment powder, which can be then mixed into the feed for farmed salmon. And there is, of course, also the synthetic option, the most dominant option in the aquaculture industry at the moment, which is petroleum-based, so a non-renewable source, really. And through various chemical reactions, we then receive a synthetic astaxanthin, which is also being added to the feed at the end. And so we have a difference between natural and synthetic pigments by source, composition, but also molecular shape, which I find really interesting. And in 2022, there was a study actually looking at whether the molecular shape has an impact on the bioavailability and the functionality, the physiological functionality in humans. And I recommend really reading this article because it describes the molecular shape of natural pigments more of a key. It looks like a key that goes into a lock, whereas the molecular shape of the synthetic astaxanthin may be a little bit more difficult to turn around the key to open the door. So it's quite interesting study. Moving on.
You want the previous slide or?
And no, you can just go on. Thank you. So, natural pigment sources, including Panaferd, are widely accepted across the global market. And Panaferd meets the requirements of the EFSA, the FDA, FAMI-QS, OECD guidelines, and can be used in the organic production of fish. It is tightly controlled, not only in quality, but also hygiene and environmental management. But Dominique has already mentioned, of course, there's room for improvement. This is important because consumers, especially in the EU, are really looking for transparency and safety of the foods they are eating at the moment. And we just started to talk about consumers. So Paula, could you go to the next slide? Thank you so much. Okay, so let's move on to a national US survey that we have commissioned this year. And this data represents 500 regular US salmon buyers, and they cover really all regions of the US. They're from the West, Northeast, South, Midwest. And we had 245 male participants, 245 female participants, and 10 diverse different participants. So really a wide range also of income categories. And we see a strong representation from premium to organic, farmed and wild salmon buyers, which gives us quite a balanced picture of the US market. Thank you. And this is really where things get interesting. So in the US and across all buyer types, more than 90% want to know whether salmon pigments are of natural or synthetic origin. So organic and premium salmon buyers place the highest importance, which confirms what we see in the market. Color, naturalness, and transparency are just becoming tightly linked. And when consumers learn that salmon get their color from pigments in the feed, natural sources are consistently preferred. So this opens up really an opportunity for brands and retailers to differentiate their products by highlighting their natural pigmentation in salmon fillets or trout fillets, for example. The next question is, does this preference translate into higher value? And if you look at this data, yes, it does. We see a clear willingness to pay 11 to 20% more if salmon or trout were fed with naturally derived pigments. So across wild, farmed, premium, and organic buyers. Interestingly, also wild salmon buyers are interested in that. So maybe there is some sort of transformation from wild salmon buyer to farmed salmon buyer. And this shows that natural pigmentation is not just nice to have, it's really a value creation. Now, how do consumers learn about color and added value? Interestingly, 49% actually read it on the packaging or preferred reading it on the packaging directly attached to the product itself. But also there is, 41% like to just visit the brand websites and 40% rely on social media. So the conversion about color is, the conversation about color is already happening publicly, at least in the US. And unfortunately, often without the right context at this moment. This is why we need to become a little bit more transparent. There's a lot happening in the US at the moment, shifting the attention towards synthetic dyes. And there is a huge misunderstanding that if, and could you go to the next slide, Paolo? That if you, for example, and they already do it in the US, they add notes like color added onto salmon, they add natural color added, but all that sometimes does is it's a misunderstanding. People think the fish was dyed in a bucket of color. So we really need to work on the transparency here and the education of consumers. There is no standard at the moment, and this marketing tool to place color added is really in its infancy shoes. But this misunderstanding is currently actually leading a wave in the US, and we have to see it as our duty to raise awareness among end consumers and to make them understand, no, it's part of the natural food chain, actually, if you add natural pigments to the feed. Thank you so much. Next. Thank you so much. Yeah, perfect. So for Panaferd, we can say that it effectively enhances the pigmentation. It meets the nutritional standards for fish. It is also following the current market expectations, and it supports the shift toward natural ingredients and a transparent value chain. Also, it naturally aligns with the marine food web, which is very important. The carotenoids that are being incorporated in the feed when using Panaferd means that you use carotenoids that are naturally found in the food chain and that they have a natural quality. And one very nice point is also for retailers that you can shift your product from normal commodity product to a more premium positioning by using Panaferd as a differentiator or natural pigmentation as a differentiator. Yes, and let's have a look at the results from the poll, if that's okay.
We had some for each poll, and I'm showing one by one.
Okay.
So the first one is what best describes you. So it looks like some are eating, 50% are eating salmon and trout. In general, they are generically interested, and 25% feed manufacturers, 25% retail buyers.
Okay.
And of course, some don't vote because today is Friday, and or maybe they are shy.
They're already headed into the weekend.
They have all our understanding. So the second poll was, before today, did you know salmon color comes from pigments in feed? And yes, good part, 67% claim that they knew about it.
Oh, nice.
And some of them were not sure. They remain.
That actually covers what we've seen in the US. Most of the consumers did know about pigmentation in feed. So quite interesting. I guess feed manufacturers would knew from their studies, but it's great to know that end consumers that just love to eat fish have an understanding of it.
Yeah, and normally participants to these webinars are, let's say, from the industry or somehow related. So the third poll is, do you think consumers know salmon color comes from feed? And some do. That's the main answer. Some do. Okay. So, or maybe some also guess that it's like this. The other poll is if two fillets look identical, but one is naturally pigmented and one synthetic, all of them would choose the natural one. Okay, that's
yes,
encouraging.
Yes.
And then
the question I find most interesting, because the last study that I found on pigmentation in salmon and what looks appetizing was in 2001. And it was a US study, and apparently everyone wanted the most reddish salmon there is. So yeah, what's the result?
Yeah, that was the result was that all all believe that would go for the natural one. They would all go for the natural one.
But what option did they click? Option 3, 4, 5, or 6?
No, I'm talking about the poll, which was if two fillets look identical, but one is naturally pigmented, then they chose the natural one. And then the semi-last poll is when you buy salmon or trout, what's the first thing you look at? So in equal numbers, some voted for freshness, some price, some origin. They don't look, at least they among the answers is not color, but maybe some do check the color, but let's say without even realizing that they're doing it. It's more like we're less aware of checking the color, more proactively looking for freshness and price and origin because we have to read something.
Well, on the other side, the farmed fish also proposed on the EU markets are pretty high quality, meaning the color is very good, very nice. So there's no issue and no concern about that.
Yeah. So if it was, let's say, white or very pale, maybe.
Yeah, of course.
And so they voted for 3, 4, and 5.
The options. That's very interesting. Okay.
Not C.
So medium to reddish. So interesting.
Yeah.
Not the reddest, I guess.
So maybe too red might seem unreal. Or
yeah. Maybe. That's
very red looks like a wild salmon, which is quite unusual on the EU market, I would say. So it's not the case on the North American market where wild salmon can be found easily, not so much in Europe.
Yeah. That's great. So we have also some questions already.
Okay.
Let's see. I'm very jealous because they're all for you, but I'm glad at the same time. So the first question is, have other certifications for sustainable aquaculture already included requirements related to use of different pigments? And in what do these requirements request? E.g. ASC, BAP, Global Gap, Organic. So I talked about the status of the process for Friend of the Sea, but are you aware about other aquaculture certification standards position? I think you mentioned something about organic that's requesting the natural one, right?
Exactly.
Do you know
So
anything about the others, like ASC, BAP, Global Gap?
yeah, there are a few feed standards, but unfortunately, natural pigments only make a very small percentage of the feed itself, and therefore we do not actually come into consideration. Feed additives usually are not certified. So we would love to be accredited or be participating in some form, but we are such an important component because the pigmentation is a very costly business, and unfortunately many try to save on this component because there are no standards involved. So we are always looking to participate with NGOs and raise awareness. But yeah, it's a difficult topic, especially because you cannot see the difference automatically when you have fresh salmon in front of you or fresh trout. So it's critical, but at the moment, very hard to distinguish.
And so you're not mentioned, I mean, pigments are not normally part of the requirements for certification.
Mm-hmm.
Okay.
Yeah.
Okay.
Yeah, only in the organic standards, as I said.
Yeah, only organic. If you buy organic fish in Europe, then you can expect that natural pigments were used.
Okay. And yes, you were talking about price. There's another question. What is the actual price difference between the pigments alternatives and also considering the efficacy?
Mm-hmm.
Yes.
I may answer to that question, Paolo. It depends, of course, on the pigment alternatives you use. As I mentioned, there's mostly three forms: the algae, the yeast, or the bacterium form. So it depends on the ASTA concentration. In terms of course, color scale you are looking for, if it's let's say according to the scale Caroline was showing, if you look for 3, 4, or 5 colors, the inclusion of ASTA won't be the same. But overall, it's a range between 5 to 20 cents euro per kg of salmon or trout. So compared to a synthetic ASTA, okay, I mean, in order to get the same color, if you want to use a natural carotenoid, you're going to pay something like 5 to 20 cents per kg of fish. That's pretty much the difference for the same efficacy.
And what does it mean in terms of percentage on the overall cost of the production? Is it possible to estimate that?
Yeah, that's what I said. It's going to cost 5 cents to 20 cents per kg of fish, meaning salmon or trout. So it depends on your targets in terms of color.
Can you remind us on the average cost of 1 kg of salmon?
The production cost is something like, it depends on the size again, but let's say 4 to 5 euro per kg, something like that. So that's the average cost for, depends, I'm talking about 3 to 4 kg fish.
So it's quite
it's a minimal cost.
Minimal,
yeah. If I told you need to pay 10 cents more to get a natural color at the end for the consumer, that's something very acceptable.
Mm-hmm.
But again, it's not a priority concerning the actual salmon and trout industry. There's no visual difference between the two. So it's more related to, as Caroline said, to the awareness of the industry, of all the stakeholders.
Mm-hmm.
Again, there is a trend for the decarbonization of our economy, including all the fossil energies. So one day, more or less, it's going to also touch the micro-additive, and astaxanthin is a micro-additive in the overall feed industry, of course.
And there's a last question. which is quite interesting. Doesn't the pigment mislead consumers from actual quality of the meat?
So can I answer? I find that an interesting question. You must ask yourself, is wild salmon misleading his color by eating pigments which is already available in the wild? I think this question is, no, it's not misleading. It's pigments are a nutritional requirement. Fish have to eat it in order to grow. Fish have to eat it in order to reproduce efficiently, even in the wild.
I guess the reason for the question was more like, as it happens with tuna coloring. I'm not a scientific expert on this, so I'm just trying to provide an interpretation to the question. But we are all aware that at least for some meats like tuna can change color if they are not properly maintained in the cold chain, etc. And this would indicate that the meat itself is, let's say, dangerous or implies some risk if eaten.
Histamine content.
Histamine. And does the pigment impact this, or does this process would continue anyway to, let's say, alert consumers in case it was needed, or it's not the case in
salmon, it's
salmon.
Trout and salmon, it's not really the case. So carotenoids are really added to give health benefits to the fish, and the fish, of course, then automatically seeing the flesh receive its color automatically. But of course, there's also a certain color chart, so a color that you want to achieve in order to achieve a certain quality of salmon. There is a table of different color charts that retailers can have a look at and be like, oh, this salmon is this color, so it's that quality.
Okay.
I sell premium salmon, so it must be a good color, but it's also an indicator of health. If you have a salmon flesh that is very light, you can also assume that this fish was struggling. Yes, and may have not the best nutritional value.
Okay.
So it is not misleading in that sense. It's just a outcome of having a nutritional complete diet.
Yeah, I have a last question. You talked about antioxidant properties of some of these carotenoids. Does it mean that if more is in the fish, more antioxidants will be eaten by humans when eating the actual meat? Or if it's more red?
Yeah. Shall I answer, Dominique, or?
Yeah, you can go ahead.
Yeah, definitely. So as the fish is consuming the antioxidants, it's incorporated into the flesh as well. And the more efficient the antioxidant works, the more it protects the flesh and maintains its stability, for example. And this is then also consumed by the human. And the antioxidant pigments are not disintegrated by digestion. They're actually being incorporated into our own body.
Okay.
So it's not like other macronutrients that we are ingesting. It's a nutrient that is deposited in us.
Okay.
So it's super interesting. It's it has a lot to do with metabolism, and but at the end, yeah, it does influence the quality of antioxidant does impact also at the end the consumer. If you look at it from a purely physiological point of view.
Great, that's very interesting. We went a bit over time, so I think we have no more questions. I will leave it here then, and I really think that we provided a lot of interesting information and consideration, and I really appreciate your willingness to participate. You're accepting the invitation to speak at this webinar, Dominique and Caroline. So
Thank you.
I'm sure that among the audience, if anybody is interested to be into contact with Dominique or Caroline, you have the details in their presentations, the contact details, and I will just make sure, as I have the Caroline one, it's caroline.candebat at anciglobal.com. So feel free to contact her and Dominique, and contact us in case you cannot find the details, and we will forward your emails to them.
Yeah, thank you.
Thank you all so much, and have a great weekend.
You too. Thank you, Paolo.
Bye.
Bye-bye.
Help our planet with this first step. Follow Friend of the Sea and Friend of the Earth across our social media. Like this video and subscribe to our channel. Your follow and subscription helps us spread the sustainability message to everyone. Let's build a better world together as sustainable friends.